Hello and welcome back to our lecture about testing AsyncIO applications. So, testing is a very crucial part of any software development process, and AsyncIO applications are not exception. So, testing asynchronous code presents some unique changes due to its concurrent nature. So, in this lecture, we will explore techniques and best practices for testing AsyncIO applications efficiently. So, let's get started. So, when testing asynchronous code, we will need to define test cases as a synchronized function using the asyncdef syntax. I don't know if you're familiar with PyTest. You have PyTest and UniTest. I work with both of them and decided that the best suits for me is PyTest. So, if you didn't knew PyTest at all, this is an excellent example. So, the pytest.mark.asyncIO decorator is used to mark the test function as asynchronous test case. Inside the test function, we can call the and await the coroutine being tested, the myCoroutine function. In this example, we can use the assertion to verify the accepted behavior of the coroutine. So we have the async def myCoroutine that await for 1 second and then return 42. In the actual test, we have the test myCoroutine. The result is equal to await on the myCoroutine, and we use the assertion. Don't worry, in the next lecture we will create our own test. So, we can also testing with event loop. So, in this example, we create an event loop using the AsyncIO get event loop and run the test case using the loop on the run until complete. This test case is defined as asynchronous function, the test my coroutine, that calls and waits the coroutine to being tested. Assertions are used to verify and expected behavior of the coroutine. So now we will use the event loop. We have the main, we get the event loop, and we wait until all the tests are completed. So we can also test on streams. Testing protocols and networks communication can be done using the AsyncIO streams. In this example, we create a test case that starts a server with the protocol being tested, the myProtocol function. We then establish a client communication to the server using the open connection. The test case sends data to the server, reads the response, and asserts the accepted behavior. The server is closed after the test case is completed. So we have the myProtocol function gets reader and a writer. From the reader, he reads the first 100 and decode data. He checks if the actual data after the decode is a low server. If it's right, the test has passed, and if not, the test doesn't pass. After that, the writer writes back to the client, a low client, using the drain to send back the ACK and then close the writer. In the test mic protocol, we open the server on localhost on port 0. We get the socket name and then we create a connection and get the reader and the writer. After we open the connection, we write using to the writer a low server, drain using the writer, and then check if the data is equal to the my protocol. Okay. So you also can use setup and teardown if you're familiar with PyTest already. So test fixtures are used to set up and tear down the environment before and after test cases. In this example, we define asynchronous fixture, my fixture, using the pytest.fixture decorator. The test case, test my coroutine, takes the fixture as a parameter and uses it in the coroutine being tested. Setup code can be placed before the yield statement and teardown code can be placed after it. So we have my coroutine. The my coroutine sleeps for 1 second and return the value that it gets. We have the fixture on the scope of the module that yield the 42, and we also have the test microroutine. If you don't familiar with setup and teardown, that's totally fine. It's not the focus of the lesson. So, let's sum up before going to some code. Testing AsyncIO applications requires specific techniques to handle asynchronous code and concurrently. Test cases for asynchronous code should be defined as a synchronized function using the async-def syntax. Following best practices such as using test framework, structuring tests logically, and mocking dependencies can improve the quality and maintainability of your test. So, let's jump to some code about testing. I see you there. Bye bye.